See if that's still blurry or not. Do you guys remember the composition of functions? College algebra?
Is that like when we're plugging in like g of x into f of x, or if it's asking for like a third?
Yeah, exactly. A function within a function, g into f or f into g. Yeah, that's exactly what it is. So basically, you think of these more complex functions as composites, and then we use a formula to make the derivative easier by viewing them as composites, because they technically are. So here is the formula that I like writing it this way. I feel like it's the easiest way to understand. So let f and g be continuous and differentiable functions. So assuming that is true, so if y of x is equal to a composite function f of g of x, then the derivative of this function, we'll call it y prime just to keep it simple. I'm trying to keep it as simple as I can so we can try to understand this. So basically, you take the derivative of the outside function and multiply by the derivative of the innermost function. And if there was multiple functions, you would just do it again. Like if it was three functions or, you know, that kind of thing. So let's do number 5 from the homework. This section and the next one are going to assume that you are pros of derivatives, which is may not be the case just yet. But while you're doing a chain rule, a product rule could happen, a quotient rule could happen, power rules all at the same time, maybe two of them. It depends. So I'm going to write it this way. That way we can follow the formula. So let's say that y is equal to 2 times 5 minus 7x to the fifth. So what is the outer function here? What is the inner function? We'll call f the outer, g inner.
Well, g is 5 minus 7x. So that means f of x would be 2 to the fifth.
Yeah, 2 times x to the fifth. Yeah. So this function, the outer function is just raising something to the fifth, right? The inner one is 5 minus 7x. Is that clear?
Yeah.
Okay, so if that makes sense, the derivative, just follow this formula, right? To the derivative of the outside, which is going to be the power rule, and then times the derivative of the inside, which would be the derivative of this guy, whatever that is. So here we go. So here is the derivative of the outside. 5 minus 1, bring down the 5, right? That's a power rule, times the derivative of the inner function, right there. So we'll do the derivative of the inner part on the next step. So this becomes 10 5 minus 7x to the fourth. What is the derivative of this inner part?
Is it just -7?
Yeah, just -7. So that's it. We did the outer, did the inner. So that would be -70 times 5 minus 7x to the fourth. Is there any questions on what just happened?
Yeah, how did you get the -7?
Oh, so derivative of 5 is 0. Derivative of -7x will be -7. Do you see this derivative here?
Yeah.
Okay, cool. So
Okay.
that's
Thank you.
how you get the -7. The book uses the alternate notation, but I feel like this one's easier. But you can use whatever you want, of course. Um, so what they do, say if y of x is equal to f of g of x, they say, and u, they label u to be the inner function. Then dy dx is equal to dy du times du dx. Sorry. So you can take derivative of this guy with respect to dx, or x rather. That would be this piece. The derivative of this with respect to u would be the outer function. But you can use either one. I think the one we used earlier is a little more clear when you first start out. But anyway, do you guys have any questions on 5? Does that make sense? Okay. Let's move on then. Do another one like this, just get the practice. One second. Okay, it's number 6. Similar to the last one, just a little slightly different. Pretty much, it's the same technically. So 2/3. So what do you guys think is the outer function? and inner.
X to the 2/3.
Yeah, x to the 2/3 is the outer. Inner will be right here, right? Excuse me. Yeah, thanks, man. Okay, so derivative of the outside will be 2/3 times this. 2/3 minus 1, that's my power rule. Well, you know what? Let me write the formula real quick because we should have reference to it. Sorry about that. Okay. So the outside derivative, 2/3 2/3 minus 1 times 9x plus 4 to the first derivative. So 2/3 minus 1, that'll give us a negative, right? This will become 9. Okay, so from the top, right? Power rule for the outer one, 2/3 minus 1, I mean negative 1/3. Bring down the 2/3. Derivative of the inner one, derivative of 4 is 0, derivative of 9x will be 9. And that's pretty much it. So the third and the 9 will reduce if I put the numbers together. And this is a negative power. So just bring it to the bottom. So this will cancel, leaving me with a 3. 2 times 3 is 6. So I'll be left with 6 over this garbage. There we go. Do you have any questions on the second example? Any questions on number 6?
I'm okay, thanks.
Okay. Just let me know. I'll move on to number 10 then, something different. Find the derivative. This time it'll be y equal to So outer function, what is it going to be?
X squared.
Yeah, it's just going to be x squared. The inner part is going to be what?
1/x-3.
So you see the annoying part this time is the inner derivative will be a quotient rule, right? So that'll happen. Sometimes you'll have quotient with a product with whatever. Life sucks. Okay. So the outer derivative is no big deal, right? Y'all see this is just a power rule. The derivative of the inside is a quotient, and you just got to deal with it.
I have a question. Is there an easier way to remember how to do that quotient rule? Because I always get it mixed up.
Was there one more time?
Is there an easier way to remember how to do the quotient rule? Because I always get it mixed up. Like I always have to look back at my notes and
Oh,
multiply.
like remember the formula?
Yeah.
Well, we used to do the same myself. The pattern I noticed recently is that the quotient derivative of a quotient is always going to be uh derivative of the first part times g. So I always think I'm starting up here, take that derivative times the bottom minus, now that I've done the first one, I have to do the second times the other one over g squared. But I always double check myself because I'm like, is that right? Even though I've done it like thousands of times. I'm checking right now, it just does. I don't want to start the quotient rule when it's wrong. But
Yeah, that looks simpler to remember.
yeah, just start with the top. This is the same for product rule. So I memorized both of them in the same way. First one time for derivative of the first times the second plus derivative of the second times the first. Only difference for quotient is it's a minus and a square at the bottom.
So I have another question.
Yeah, sure. What's up?
So I got here a little late. How did you on the f of x? How did you determine that that was x squared?
So you got, I mean, it's kind of hard to see. It's easier to start with the inner one. Okay, if this is the inner, right? The inner is just a rational function. But what does the outer function do? Well, the outer function squares things, and that's what a quadratic does.
Okay, got it.
Like if it
And
was a
that's
square root on here, you would put a square root function or something.
and in order to do the quotient rule, we need to determine what the f of x is and the g of x, right? The inner and the outer.
To do quotient, um, you have to just you gotta anytime you have a quotient, um, you have to make sure you put it in this order, right? I know it's kind of confusing to call this F and G after I call this, but this is just how I memorize it. But it's going to be the top part times the bottom, derivative of the top times the bottom minus derivative of the bottom times the top.
Okay.
So right here, derivative of the top is going to be a 0, right?
Okay.
So at that point, well, that part doesn't really matter anymore, but let's go ahead and write it anyway. Bottom is this minus the, well, let's show the step. So derivative of the bottom minus the derivative of the bottom times the top, which is a 1. So now we have 2 over x minus 3 times this garbage. This will be 0 times x minus 3 minus, this will be a 1, right? So this part's gone. So we'll be left with negative, well, let's show the step. That makes sense. Oops, that should be a 3.
Yes, thank you.
Is the power supposed to be two or three for x
3.
minus 3? Oh, a 3? Okay, thank you.
Yeah, it's bad. I wrote that shitty. Okay. How are we doing? Let's see. Oh, no, let me give you oh, I think I already gave you that. That's fine. Let's move on. You guys cool on 10?
I'm good, thank you. Just to clarify, this is 3.4, right, that you're going over?
I believe so. Let me check. Yes, yeah, it is. Let's do one more and then I'll give you some time to try it out. That way you can ask questions. All right. So let's do a trig function. So here, this one's pretty obvious, right? What's the outer function? And inner.
Cosine and 3x for the inner.
Yeah.
So f of x is considered the outer, and then g of x is the inner.
Yeah. So the outer, what's the derivative of cosine? You guys remember?
It's a negative sine x.
And negative sine x.
Yeah, so it'd be negative sine, but you leave it as 3x. Then do the derivative of the inside. Derivative of 3x is the inner part, so it'll be 3, right? Excuse me. All right, let's spend 30 minutes or so trying out these questions on 3-4. And then if you have any problems or concerns, or if you're stuck on anything, let me know. Before we let y'all work, you guys have any questions on 17?